Did you know you can assess the quality of predicted protein structures in Jalview? Imagine you've got an alignment of protein sequences. You've colored this to explore various properties, discovered structures using 3D beacons in Jalview, and now you're examining the predicted models available from various providers. You pick one and begin to carefully inspect it. Naturally, you're going to find yourself asking, is this even good enough? It looks pretty, but is it structurally sound? Which regions should I be happy about? And which regions should I discard from my analysis altogether? Jalview has a number of confidence scores to help you demystify the wild west of protein structure prediction. One metric it displays is the pLDDT, short for Predicted Local Distance Difference Test. This score is developed by AlphaFold and based on how accurate the distances between consecutive residues in the protein backbone are, and how confident you should be in the estimation of the location of each residue. Let me show you an example. Here we have an alignment of EPAS1 proteins from the human, mouse, and rat species. Now I'm going to see if I can discover predicted structures for these sequences from the 3D beacon search in Jalview. And then we look into visualizing the pLDDT scores both in the alignment window as well as in the 3D viewer. So to begin with, I'm going to select all the sequences so we can do it for all of them at the same time. And then right-click and go for 3D structure data. Okay. So it seems that we don't have any experimentally determined structures for EPAS1 in rats. Let's see if we can find any predicted models. Great. We have predicted structures for all three sequences from AlphaFold. We've got superposition enabled, so the three of them will overlap each other when we load them in the 3D viewer, which is pMol today. And pMol is launching in the background. And this is the point where we brace ourselves for some detective work. The first step is to extract the pLDDT scores for the models from the AlphaFold database. For this, we'll need to go back to the alignment window. We highlight the entire alignment once again. It's already highlighted for us. And now, when we right-click on any sequence ID and go for selection, because we've just made a selection, we'll see the Add Reference Annotations option here. So the pLDDT scores are loaded as AlphaFold reliability graphs in Jalview, along with the secondary structure and the predicted aligned error matrix, 2 additional annotation tracks, 2 additional pieces of information. Now let's drag this up here so we've got more space to have a proper look at these tracks of information. And I'm also going to enlarge this first AlphaFold reliability track for the EPAS1 protein in the human species, just to enable a better view of the scores and how they vary. So in this predicted model, we seem to be doing well initially. There's high pLDDT scores, lots of blues, until we scroll to the right. And now we'll encounter a lot of orange dips in the model's overall quality, indicating that the scores are below 50%. Okay, now we can color our alignment according to the pLDDT scores we've just extracted. This can be done by going to the color menu in the alignment window up here and selecting by annotation. Immediately, we see color pop up over our entire alignment. By default, in Jalview, when this dialog box is first loaded, the coloring will be according to these two colors specified here. Now, to color according to the pLDDT score, which is what we want to do, we can choose AlphaFold Reliability EPAS1 Human in this drop-down menu here. And at first, nothing changes. And this is because the color scheme activated at the moment is this default one I mentioned earlier. Now, when I activate this tick box over here, use original colors, this should now load AlphaFold's default color scheme, which was developed to specifically interpret the pLDDT score. Great, so the entire alignment has been colored according to this pLDDT score, but for EPAS1 in humans. And if I take a peek into the PyMol viewer now, we can see that the overlapping protein structures here are also colored the same way. Now we can change this, so each sequence in the alignment is colored according to its own pLDDT scores by clicking on this tick box, per sequence only. Great. So the coloring in the alignment window, as you can see here, has changed to mirror individual scores for each of the three sequences. Now, what if we wanted to visualize our sequences according to a range of pLDDT scores? Say, for example, I wanted to see all parts of the alignment where the scores are below 40%. I will choose below threshold and plug in 40% here. Jalview has now highlighted all the residues where this is the case. And if I move the slider here, Jalview highlights all the regions according to the changing threshold and the condition selected. As you can see here, this slider also corresponds to this dotted line on the graph here. Selecting no threshold will give us the error shading as it is once again. And now we're on to the final part of our tutorial today. And in this part, I'm going to show you how Jalview enables us to select or hide sequences according to pLDDT scores. This can be done by right-clicking on the annotation ID of the AlphaFold reliability score and choosing Select/Hide columns by annotation. Select has been chosen by default. So now let me plug in a value of 90 in this box. And when I press OK, we can now see that all columns where the pLDDT score exceeds 90% have been selected in red. Once again, we can move this slider to apply the AlphaFold color scheme onto our alignment. Now we can also hide columns according to the pLDDT score. So I'm going to go for 50% here and below threshold. And what that's done is that it's obscured all the residues which satisfy the condition. And this is also reflected in PyMol, the viewer we are using today, accessible from Jalview. All the regions with pLDDT scores below 50% have been grayed out. And that's it for today. In this video, we explored a number of concepts. We saw how to load the pLDDT scores for predicted protein structures in Jalview, how to color both our alignment as well as the three-dimensional structures loaded in the 3D viewer according to one pLDDT score applied to all of them, as well as their individual pLDDT scores. And finally, we explored how we can select or hide parts of our alignment according to the pLDDT score in Jalview. In the next part of this series, I will be exploring the predicted aligned error matrix in Jalview, which is another estimate of model quality. Happy Jalviewing, and I hope you'll join me in the next video.